Hey, it's Cory and Ryan with Cranberry Alarm Ri3D, and in this video we're going to be going over our control system on the robot, highlighting things like the Thrifty Bot and Grapple time of flight sensor, laser can, the Redux color and can, as well as the new Thrifty Novas and our mostly Neo and Spark Max motor control system. So diving right into a quick overview of this robot. We're using no pneumatics this year. All of our actuation is done with motors, and I can say that all of our actuation is done with Neo 1.1s. Typically, you would have to drive your Neos with Spark Maxes, but this year Thrifty Bot came out with a new motor controller called the Thrifty Nova, and we have those running our outtake wheels. We'll be able to lift up the elevator and show you those in more detail later, but let's see if we can get a zoom in on the belly pan a little bit. I know it's a nest of wires, but we're still running with a PDP-1, and we're almost filling it up with the number of motors that we have, but it still suits our needs, and it's still something that is readily available. You don't have to spend money on a PDH or a PDP-2 if you're not looking for the upgraded features. You might notice that we do have some pneumatics components mounted there. We're not using them. We're mostly using them for dead weight right now. Our drivetrain is driven by Neo 1.1s, and there are Spark Maxes on either sides of the motors. Since you're limited by the encoder wire of the Neo, typically you don't want to extend that. Extending that causes some issues. You want to place your Spark Maxes or motor controllers nearby. We're just running with normal 6-gauge wire. I know that a lot of teams are thinking about upgrading to 4-gauge, and that has some benefits as far as drawing more power from your robot. But being an Ri3D, we're trying to keep it simple. One of the main features of this robot that is unique to many years is the elevator, and how do you get all of your wires to the top of the elevator. So we're going to come around the robot right now and show you this double cable track. We have 4 motors on our elevator carriage system. And so we have 4 double pairs of red and black to run power to those 4 motors and motor controllers. And then as well in there, we have a 12-volt supply to power a couple sensors, and then 2 runs of CAN up and down to get a full CAN loop. So let's actually show the elevator going up and down and what that cable track looks like. The routing is from the top of the stationary stage. We loop up and come down to the bottom of our second stage. And the main characteristic of this design characteristic you need to worry about is that you basically need to travel half of the length of your full extension. You're already going up half by going up your stationary stage, and you need to handle the rest. So let's go ahead and pull this up and show the cables. We're in brake mode right now, which is why we're struggling. But you can see, we'll stop right here. The cable track is following along nicely. We just have these mounted with some flexible polycarb. The flex gives us some ability to have misalignments and not worry about the cable track breaking or deforming in any weird ways. But this is more than adequate for what we need, and we found it to be a very successful way to get the wires from our main belly pan up to our second stage of our climber, our elevator. While we have this elevator up here, I'm going to point out a couple of sensors on here. Let's let it drop down a little bit more.
Yep. So we've got 2 sensors on top of the coral chute to be able to detect the coral traveling through the game piece path. So on the back here, we've got the laser can by Grapple Robotics and the Thrifty Bot. So we're using that to make sure that the coral is clear of the elevator path after we intake it. So when the coral drops in, we want to make sure that this path is clear so that we can safely raise the elevator.
You'll notice that the coral sticking out, the elevator's raising up, it's going to intersect with that 2x1 at the top.
Yeah, so we just want to make sure that this is clear, and then once the laser can reads that there's nothing there, we're safe to raise the elevator. On the front, we've got the Redux cannon color. So it's a combination IR proximity sensor and color sensor. And it has the ability to transmit that data over CAN. And then it also has 2 digital outputs that you can use to trigger motors or RoboRio. And obviously, the color sensor isn't super useful for this year's game, but the proximity sensor is useful because we can use it to tell if the game piece is at the front and when it's exited. So during auto, we can have it shoot out, we know it's exited, and then we can move on.
Yeah, super great to have sensors moving towards the CAN bus, I think, in the FRC ecosystem. Sensors like this would be even more annoying to mount on an elevator if they had 4 or 5 cables that they needed to support them and run those all the way back down to the Rio. So thank you to vendors for upgrading their catalogs with these new CAN sensors. We love them. And we're looking forward to exploring how the laser can and the Canon color work for this year. We'll update you more with how they work once we've tested them and put them through the ringer a little bit more. But I think that's a good overview of our robot and the control system specifically that we're using to power all of the motors and also detect the game pieces when they're in our robot. Stay tuned for more videos from Cranberry Alarm Ri3D on fun.